So now that we've finished all of the Lewis structures, I just wanted to do one slide that refreshed your memory of the exceptions. Okay, so everybody would like 8 except for a few people. So some people, remember we said, are happier, more stable with more than 8. So these are guys that are in row 3 or below. And these are going to have empty d orbitals. And this means they can have more than 8 electrons, okay? Remember, we check to see if it's going to expand based on formal charge. So just because they can expand doesn't mean they always do it. All right, let's jump down to here real quick, incomplete octets. Okay, so remember these are less than 8. We really talked about hydrogen, who's happy with 2 electrons. Two other ones that are really important are boron and aluminum. They're happy with 6. Those are the 3 that you're mainly going to see. Is you're going to see boron and aluminum with happy with 6, and you're going to see hydrogen happy with 2. Those are the ones you just got to remember are happy with less than 8. Now, this guy we haven't done, odd number. That means that they're going to, when we total them up, they're going to have an odd number of electrons. So an example would be NO. If we looked at NO, N has 5, oxygen has 6, and O has a total of 11 electrons. So he has an odd electron. So what happens is these guys will have one unpaired electron. Just one electron chilling. Okay? We call these guys free radicals, the whole molecule. It's the name of the molecule, not that electron. Free radicals. And these guys are very reactive because we don't like an electron to be by itself. So kind of just to show you how we would draw this, you have your N and your O, and you make a single bond. So we can go through our rules. You don't have to figure out who went in the middle because there's only 2. Then we want to make the oxygen happy, so we put 6 on him, and I only got 3 left. Okay? Nitrogen now, he has 1, 2, 3, 4, 5. He wants 8, so what we're going to do is we're going to move 2 from the oxygen to make that double bond. So oxygen still has 8, 1, 2, 3, 4, 5, 6, 7, 8. And our nitrogen has 1, 2, 3, 4, 5, 6, 7. Now you might say, well, why did I put oxygen full before nitrogen? Nitrogen is less electronegative. So that means oxygen needs to have all of its electrons before nitrogen. So you can almost think about nitrogen being the central atom, and we're doing all the other ones first, okay? So this is what the Lewis structure would look like. I'm never gonna have you draw one of these. I want you just to be aware that these exist. And if you're reading stuff like in the newspaper or an article, you might hear about free radicals because these kind of molecules are what really leads to cancer and those kind of things. And these kind of are what happen, especially if you're out in the sun. The sun can cause free radicals to form. This is also what happens when you age. Free radicals form in your body and they're very reactive, so they react, and this is usually what leads to cancer and those kind of things. So I just want you to be aware that they exist, but I'm not gonna make you draw any of them. All right, so we are done with drawing Lewis structures. The next lecture is just going to be talking about bond length. How long is this bond? How close together are these 2 atoms?